In this video, I'm going to show you how to do one of the homework problems where you have to graph a polynomial in MyLab Math. Before you do the graph, they're going to want you to answer some questions. So the function we're graphing here is f of x equals x to the third minus 3x squared minus x plus 3. And the first thing we need to do is determine the end behavior. So my degree here is 3, which is odd, and my leading coefficient is 1, which is positive. And so that tells me that the graph is going to fall on the left side and rise on the right side. Next, I need to find the x-intercepts. And so this is where I need to set the function equal to 0 and solve. So 0 equals x to the third minus 3x squared minus x plus 3. For terms, that means we're going to use factoring by grouping. So split it into two groups. That's going to be x squared times x minus 3. X squared is the GCF. And then over here, we're going to have x minus 3 and a minus 1 in front. So I get two factors, x squared minus 1 and x minus 3. Now x squared minus 1, that's a difference of squares that I can factor again. And so that is factored into x plus 1 times x minus 1, since the square root of 1 is 1. And then I have my third factor here, that x minus 3. And so setting each one of these equal to 0 and solving, gives me my three solutions of -1, +1, and +3. So now we want to look at the multiplicity and determine where the graph crosses the x-axis and where it touches and turns around. Now going back to my factoring, each of these factors has a multiplicity of 1 because there's no exponents on any of the sets of parentheses. They all have multiplicity of 1, which means that the graph is going to cross at all 3 points. So it's going to cross the x-axis. I'm going to choose A and then type in all three values, -1, 1, and 3. And the second part of the question is, at which x-intercepts does the graph touch the x-axis and turn around? And that's going to be none, because it's going to cross at all of them. So I would choose answer choice B for that. Part C says to find the y-intercept. Now the easiest way to do this is to go back and look at my function and look for the constant. Or I can think about plugging in 0 for x. Either way, my y-intercept is going to be 3. And then part D is asking about symmetry. So thinking about my x-intercepts, I have -1 and 1, so that would be symmetric, but I have a third x-intercept at 3, and I don't have one at -3. That tells me that there can't be any symmetry, because in order for there to be symmetry, I would have to have a point at x equals -3 if there were a point at 3. And so this is going to be neither. Generally for these problems, you'll see that they're probably going to be neither, but it's still good to think about it. And lastly, I can do the graph. So click to Enlarge Graph. Now the tool that we're going to be using in the graph toolbar is the one in the middle of the second row. It's called the 4-point cubic tool. And it says 4-point tool. That means that you need to click on 4 points all together to make the graph. Now for this problem, I did end up with 4 points that I already have, so I don't need to find any additional points. I have my 3 x-intercepts at -1, 1, and 3, and I have my y-intercept at +3. So I'm going to go ahead and plot all of those. Y-intercept at +3, x-intercepts at -1, 1, and the third one was at +3. So I'm going to click on that. Once I get the 4 points, it's going to put the graph in. Now I want to think about the end behavior and if the end behavior matches what it's supposed to. What I said originally was that the graph was going to fall on the left and rise on the right. And it makes sense because that's what the graph does. So I can click Save and check my answer. And there we go.